No sound in what I do. So anything I write, it changes. Okay, so we'll get into it. Area of a square, obviously A equals S squared. That's, you just take the side. And then a rectangle is the length times the breadth. Yeah. So you can write as a reminder, or we can just, it's just a rectangle. Length times breadth. Okay? Now, triangle, A is half of the base times the height. Any ways you can write it, it's also written as A equals BH over 2. You can write it as well. So that's important, it's the perpendicular height. I don't know how to email notifications now. So it's important, it's the perpendicular height, okay? It's a right angle. So it also means that if you have a triangle that's sort of obtuse like this, maybe have a triangle like that, what you need to do to find the height is you have to extend it out. That's a right angle, and that ends up being the height, okay? And the base is this length here. That diagram makes sense. That's the base is the base of the triangle, but the height has to be a perpendicular height from the base up to the top. So if it happens that the point is outside of where the base is, you maybe need to find it using Pythagoras. Familiar with it? Okay, any questions so far? You're all familiar with triangles, how to find an area of them. Height. Circles, obviously pi times the radius squared. What's the circumference? Yeah. Yes. Circumference is the perimeter of it. Okay. Remember to distinguish between the two. Pi r squared is the area. Okay. So that's an important thing. We're going to look at a couple of different things about circles, variations of circular type shapes. We're going to look at. Okay? The trapezium. Trapezium is good. Yep. So a trapezium is a quadrilateral with one set of parallel lines. Okay? Quad with one set parallel. So it's the perpendicular height, just like a triangle. The perpendicular height is the top, the two lengths of the parallel sides added together, divided by 2, multiplied by the height of the trapezium. Or the distance between those parallel sides. Distance between the two parallel sides multiplied by the average of the two lengths. That's also enough. That's the way I think about it. I always think take the average of the two parallel sides and then multiply by the distance. So how do you think about it? Yes, you will. There you go. Okay, an ellipse is the official name for oval. And I don't know if you've come across these terms before. You have A and you have B. They're called the semi-major and semi-minor axes. Right? So the longer from the center out to the furthest point is the semi-major axis. Right? And from the center of the ellipse to the shortest point is called the semi-minor axis. And the way that you work out the area of an ellipse is, instead of doing pi times r squared, you multiply that semi-minor and the semi-major axis together and multiply by pi. So it's pi AB. Okay. pi times theta. That's the way that you work that out. Just make sure you take note of this. Just let it screw over. Let's rub that. Anyway, you get the idea. Alright, semi-major, semi-axis. Up one together, multiply by pi. Okay. Look at this. Now, an annulus is a donut. It's a shape you get when you have the area between a smaller circle and a larger circle. So in this case, it's the shaded area. If you think about it, the area of it is the area of the larger circle minus the area of the smaller circle. So pi times big R squared minus pi times little r squared, which when you factorize the pi out, you can do pi capital R squared minus little r squared. And that's the area of the annulus. If you remember the formula, you can just remember it as a big circle minus a little circle. Either way. Sure, I'm familiar with the term. When someone says to you, an annulus stuff is the question is what that area is. You need to know what it is. Familiar with the terminology? Any questions? So far, all right? Now, a sector is this yellow. A sector is like a piece of a pie, however you want to think, a piece of cake, a piece of pizza, whatever. It's just this, it's called a sector. Now, the way that you work out the area of a sector is this. A equals the theta, which is the angle inside the sector, right, over 360. It's theta over 360. And that's working out what fraction of the circle does the sector take up. And then you multiply it by the total area of the circle, which is pi r squared. So theta over 360 multiplied by pi r squared. Okay, the angle inside the sector divided by 360 multiplied by the area of the whole circle. See, now in the way I would prefer. Right? So radius, we set that out. Theta is inside the circle. Easily. And we've all used this before, I believe. Theta is the angle inside. No, the answer will be in units squared, because you're working out the area of this. So if it's centimeters or whatever it is. Okay. Good. Now, some variations of this, or some examples of special cases of this formula, includes semicircles and quadrants, which are quarter circles. So instead of doing a semicircle, the theta is 180 degrees. Obviously, by definition, a semicircle is half a circle. So the area of a semicircle is just half pi r squared. Okay? And a quadrant, a quarter circle, has an area of a quarter, 1 over 4 pi r squared. So you don't put, you can put 90 over 360, and that simplifies to 1/4. But the easy way to say, well, a semicircle is just half the area of a circle. Quadrant is a quarter of the area. Okay? That's the way we think about it. So I'm just going to do a couple of examples. I'll just move this in. so I just took 2 examples, and then we'll get into the exercises. So it's actually 4.9, 4.10, the 2 exercises we're going to be covering. So the shaded area looks a bit funny. It's a bit like a eye. Anyway, find the area of the shaded area. Okay? So obviously this is the shaded area. That's clear. So any question like this is a difference question. It's total area of the ellipse minus area of circle. Okay? So that's what we're going to do. So how do we find the area of the ellipse? What do we need? Yeah, so we need to do the semi-major axis multiplied by semi-minor axis multiplied by pi. So this is going to be pi times 5 times 8 minus, what's the area of the circle? Pi r squared. Yeah, so it's going to be pi times 5 squared. And that is, somebody please tell me, 78.53. Let's say it's meters or something. So we can do 78.53 meters squared. Okay?
Wait, do you want the whole thing?
I want the whole thing. Oh, so that? .12 square. Okay? Any questions about that? So, making sure that we're familiar with how to find the areas of different things. So this is the final example. Let's find the area of the shaded region. So here we've got a rectangle and an ellipse out of it. So firstly, what's the area of the rectangle? 312, 26 times 12. Okay? And then what's the area of the ellipse? Think about it. You have to find the two. So this one's going to be half of 26, and this one's half of 12, which is 6. Ellipse equals pi times 13 times 6 equals 245. And then you can subtract 1. Okay. That's the way that you combine all the different, work out the areas of all the different figures. So either you're going to be breaking them into compound shapes and adding it together, or working out what the larger one is and taking out the smaller ones up here. Okay, it just depends on how you, what the question is and how you approach it. Yes. Yes. Like that. Alright, so exercise 4.9 and exercise 4.10 are the two